look at our do now here. We're on day 20. That's 20 out of 30 total days, guys. We're like there. We're so close. It's crazy. And on the last few days of school, we'll just be taking finals. So really, it's like we've got about a week and a half left. It's pretty nuts to think about. Anywho, let's look at our do now problems. So I wanted you to identify these quadrilaterals as parallelograms, rectangles, rhombuses, or squares. So number one, what kind of shape is that?
Rectangle.
Rectangle, very good. Why is that a rectangle? How do you know it's not a different one?
Because all angles equal 90, and then all sides are the same.
Yeah. Oh, are all sides the same?
No.
Okay, so what are the sides then? If they're not all the same, what have we got here? How could we kind
Like
of...
two sides are the same, yeah.
Yeah, you've got two pairs of equal sides. Perfect. So all, and you don't have to write this part, but I'm just taking little notes. All 90-degree angles and two pairs of congruent or equal side lengths. Okay, perfect. Everybody get that one? Good. Number two. What's that? Rhombus. Very good. How'd you know it was a rhombus and not just a parallelogram?
It's got two pairs of acute and obtuse angles.
Ooh, that is something I see there. Perfect. What is kind of the dead giveaway that it's a rhombus? What's that one kind of deciding factor having to do with sides?
Slanted lines.
They do have slanted lines, but a parallelogram could also have slanted lines.
The diagonal,
The diagonals? What about the diagonals?
they equal 90 degrees.
Yes, they do cross at a 90-degree angle. That is one of the kind of main key things of a rhombus. What about the side lengths? What do you notice about those? They're all the same. A rhombus is like a tilted square. That's how I usually like to think of it. So we've got those two opposite angle sets that are congruent. And that's going to go for all parallelograms. They all have those opposite angles that are congruent. We have what we call perpendicular diagonals. That means it makes that 90-degree. Perpendicular diagonals. And let's see, we said all sides are equal. Perfect. How about number three? What's that?
Square.
Square. Perfect. Why is it a square?
It's got four angles on the same sides.
Perfect. 4 right angles, 4 90-degree angles, and all the sides are equal. Okay, last but not least, number 4. What is that?
Same as number two.
Same as number 2. This is a rhombus.
Oh. Yeah.
I said a parallelogram.
It is a parallelogram. So the reason it's not a rhombus is because we don't have 4 sides that are the same length. The rhombus, the key characteristic there is that all the sides are the same. This one doesn't have all sides the same, and we can tell that because we have 2 dashes here and only 1 dash here. So this would be a parallelogram. That's as far as we can categorize it. Parallelogram. And got parallel sides. Y'all got that? Give you a second if you're taking notes. I'll pause it. You guys say the word when you're done. I see that we're writing. All right, so we are in Unit 3, Geometry. This is page 2 of our notes. If page 1 was the do now. And this is day 20. So, have any of you ever heard the word polygon? Any of you?
Yes.
Yes? Okay. Does anybody know what a polygon is?
Got 5 sides.
Could have 5 sides. It absolutely could have 5 sides.
It could have any.
Could have any number of sides. Absolutely. A polygon is a shape. It's a closed shape, a two-dimensional shape. So, a closed 2D means two-dimensional shape. And a polygon is only a shape that's made up of straight line segments. So a circle is not a polygon. It's not just any shape. And whenever we are looking at polygons, hang on. There we go. When we are looking at polygons, so first of all, we just had a whole unit on triangles. Now we're looking at quadrilaterals. We've been looking at a lot of angles. We've been looking at some side lengths. Now we're going to talk about two kind of key ideas here. We want to learn about perimeter and then we're going to talk about area. Does anybody know what perimeter is? Yeah, it's kind of like the distance around the shape. It's all the sides added together. So we're going to say total distance of a shape. We could also say that it's the sum, means adding together, sum of sides, side lengths. So perimeter is just looking at a distance. It's just the line that goes around a shape. And what would we define area as?
It's inside.
Yeah, it's what's inside that perimeter. It's the space that that shape ends up taking up, essentially. So for area, I'm going to say total space taken up by a shape. Or you could say the space inside a shape. Okay. So today we are going to talk about how to find the perimeter and the area of a parallelogram specifically. So to start off, let's draw a parallelogram. And it doesn't have to be perfect. I'm just gonna kind of freehand it and hope that it works. Here's my 2 lines. There's my parallelogram. We're gonna label 3 different things. The side of the parallelogram that's on the bottom, we call that the base. So this is the base. Base is usually represented by the letter B. Then we are going to call this here a length. It's represented with a little S. Last but not least, we've got a third measurement, and that's going to be from the base up to the top of the shape. This is the height. It's going to be a 90-degree angle here as well, exactly from the bottom to the top. This is the height of the shape. It's usually given with the letter H. So to find the perimeter of a parallelogram like this, here, I'll label it parallelogram. I'm gonna give you some formulas. That perimeter can be found either by adding all 4 sides together. You could do that. You could also take 2 times S plus B, and I'll explain why that works. So in a parallelogram, we know that opposite sides, how are they related to each other in terms of length? Are they the same length or are they different lengths? They're the same length, right? So if I know one side length, I know to get the whole perimeter, I'm going to need to add that twice. I'm going to have 2 sides. If I use the base as part of the outside of the shape, I'm going to end up using it twice since there's 2 of them that are the same length. So all we do is we're adding those together, but we're multiplying it by 2 since we're going to be adding 2 of them each. So this is a formula you could use. You could also do side plus base plus base. I think perimeter is one of those that you can look at it and see, okay, I'm going to add everything on the outside. Makes a lot of sense that way. So that's perimeter. And then area, we use the base times the height. We don't use the side to find area. We use base times height. And that's all there is to it. So I'm going to give you some numbers, and I'm going to make sure that we understand how to properly put them into our formulas. So let's say that this parallelogram has a base of 12 inches and a height of 8 inches and a side length here that is 10 inches. Okay. So first, let's find the perimeter using these numbers. So I'm going to start by using that formula there. So perimeter equals 2 times, what numbers do I plug into here?
10. Well,
10 is the base. Yep. And then, oh, sorry, 10 is the side, 12 is the base. Yes. So 10 and 12. So 2 times 10 plus 12. Now you could get fancy and use distribution. You could do 2 times 10 and 2 times 12, or you could just look at this and see, okay, I've got 10 plus 12 in parentheses. Let's find that first and just take that number times 2. I think that's probably the easiest way to go about doing it. So what do I do first to solve this?
44.
Yeah, 10 plus 12 is
22.
22. And then exactly right, Cheyenne, 2 times 22, 44. And it's 44 what? Inches. Good. 44 inches is our perimeter. Beautiful. Okay. Anybody have questions about that? Or does that make pretty good sense? I feel like today's a little more straightforward. Okay, last thing we're going to do. Let's calculate the area. So if area is base times height, what 2 numbers do I multiply?
12 and 8.
12 and 8. Beautiful. So 12 times 8 is what? 96. And inches, good. So it's 96 inches. Does anybody know what you do when you're finding area to the units?
Square it.
Squared, yes. So you're actually not changing the number, but since we're not looking at a length anymore, we're looking at area, we're looking at cubed, or not cubed, squared inches. We want to say 96 inches squared. That's how we would label area. That's the only big difference there. And that's it. That's the lesson today, guys. So, if everybody feels okay about that, I'm going to give you an exit ticket. And your exit ticket is solving a problem just like this. So, I'm going to put that up on the screen and then pass it out to you. Here it is. We've got 2 little problems here. This will be due next Tuesday. So, you've got a whole week. And I will end the video.